Welcome to another tutorial, Math 1100. We have a function here, which is a piecewise. Let g of f equal to x plus 3 if x is less than 1, 2 if x is equal to 1, and 3x minus 4 if x is greater than 1. Number one, we need to sketch the graph of this function. How do we sketch the graph? Well, it's quite easy. The only thing that you do is that you come up with your x and y axis. Let me draw it in the middle. Okay, do that and do that. So don't even bother yourself to do much, because here you can do that. All right, so we have x-axis here, and we go here where we are going to have our g of what? X. Just like that. Don't put y if you haven't been given y. It doesn't make sense after all. All right, so the first one is x plus 3 if x is less than 1. So if x is less than 1, you can clearly see that x is less than 1, meaning 1 is not included. So as we draw it, there are two ways we can draw it. When you draw a circle without being shaded, it means that point is not included. But if you shade it, it means that point is what is included. So we are going to get all the numbers that are less than 1. But if we start from 1, 1 is not going to be included. And here's how we are going to show it. So if I get 1 itself, I put g of x is equal to x plus 3. If I put 1 here, this becomes 4, meaning this becomes 1, 4. 1, 4. 1, 4. And if my 1 is here, and let's say my 4 is just somewhere there, this becomes that point there. But I'm not going to show it like that. I'm going to circle it like that, because 1 starting from here is not included. We're looking for numbers below. Get another number which is less than 0, so less than 1, for example 0. If I put 0 here, this becomes 3, meaning I'm having 0, 3, meaning if my, okay, let me put my 1 there, my 2 there, and my 3 there. So this becomes my 3. Now, is 0 included? Yes, 0 is included in this case, so just a dot like that. Get another number. For example, you can get and maybe let's put -1 there, let's put -2, let's put -3. This is too much here. You can put 1 there, you can put 2, you can put 3, you can put 4, just for reference sake, isn't it? All right, next, if you get any term, for example, if you get term let's say -2. -2 is actually less than 1. So if I put -2 here, I'll be getting 1. So that means I have -2, 1. So -2, 1 is just somewhere here, and that number is actually included. So my line is moving all the way from there, be passing like that. Just that I haven't drawn it properly, but it has to pass through like that. I hope you understand. So that is our line, meaning that point, it means 1 is not included. All right, so this is our first function. Okay, let me label this one A, let me label this one, let me label them by colors, A, B, and let's label the other one with C. Okay, so this one here is our A. Now let's go to the next one. The next one is which one? B. Okay, for this one, here's what we do. X is 1 on the point x equal to 1. This is just a single point, right? It's just 1, 2. It's just 1, 2. So 1 is here, 2 is there, so this is just a single point. Now, are we going to circle it or just shade it? We're going to shade it because x is included. Clear, right? Just leave it like that. Just a single point. 3x minus 4. 3x minus 4. And x is greater than 1. So again, we are starting, if we start from 1, we are going to just circle it. So if I get 1, I put in here, all right, I'll be getting 3 minus 4, which will give me -1. Is that right? Meaning down here, I have -1, -2, -3. So I can put 1, -1, 1, -1. I'm not going to shade it, I'll circle it like that. Is it making sense? exactly. Then if I get another number which is greater than 1, for example 2, I put there, this becomes 6 minus 4, which is now 2 comma 2. Now 2 comma 2 is somewhere there. There. That's there. All right, I hope we are seeing. Then if I get another one, let's say 3, this becomes 9 minus, which is now 5. Now becomes 3 comma 5. 3 is there, 5 is somewhere up there. So this curve or this graph now becomes, it comes like this. It will be going like that. Let me just erase that part. But this is how it will be going. And this one we can label it as C. This one was supposed to label it as B. Just like that, you are done. By showing this to Maseko, it means that point alone is not included. Then you've sketched. Then the next part is telling us to find the limit of g of x as x approaches 0. So how do we find the limit of that as x approaches 0? All right, so let's check properly. Now, let's be careful here. We are not just going to get the entire thing we start evaluating. No. Here's what we say. Since x approaches 0, let's come to the condition. This one says x less than 1. X less than minus 1. Meaning, where are we starting from? We're starting from 0, coming down. This one, x equal to 1, is out of the topic because here 0 is not even part of that. X is greater than 1. Can we get 0? All right. If all the numbers are greater than 1, no. But this part here agrees with the statement that x approaches 0 because x is less than 1, meaning it's starting from 0. So the only function we are going to get is g of x of that. So we are going to say our g of x we are going to get is just x plus 3, which is between x less than what? Sorry, which x less than 1. So here now we are saying the limit of x as x approaches 0 for which function? For x plus 3. That's all. Of which you can just put 0 there, plus 3, and you get 3. Therefore, the limit as x approaches 0 for g of x is just equal to 3. The last part, but not the least, is asking us to state with justification whether f of x is continuous. Easy. G of x continuous at x equal to 1. Let's find out. Is it continuous at x comma 1? Now, some of you, when we say, oh, is it continuous? It needs to be evaluated at that particular point. All right, the limit must exist at that particular point for it to be continuous. All right, that is what we try to say by continuous. All right, so let's get our functions. We have, I think from the graph you can see we've got the left side and the right side. So this one represents the right side, or this one represents the left side. Or what we need to do is that evaluate these functions at x equal to 1 and see if they are equal. Now, I'm just from saying, for a function to be continuous, it must be able to be evaluated at that particular point, and the limit must be equal to actually what? In our case, to be equal to g of 1. So, at x equal to 1, right? Meaning our limit as x approaches 1. This is what it means of g of x. All right. Now we understand that both of them they involve 1. So let's now evaluate the left hand side. The left hand side is actually coming from this part here, which is less than. So x plus 3. Okay. So the limit as x approaches 1 from the left hand side, the function g is to be 1 plus 3, which is just equal to 4. Because we're getting the one which is on the left side. If we get the right hand side, we're saying the limit as x approaches 1 from the positive part, isn't it? Of g of of g of x. Now in this case, the g of x we are getting is the one which is on the right side, which is 3x minus 4. So this becomes 3, 1 minus 4 to give me negative 1. The question is this equal to that? No. So the left hand side is not equal to the right hand side. Hence, okay, at x comma 1, the function g of x is not continuous. That's all. You're welcome.